All right, so you guys are here for assemblies, and then it'll be productivity and automation. The automation is kind of lame, only because there's way better ways to do things in SolidWorks than to automate things than doing it in SolidWorks directly. But I will show you some tools that will help you see movement, stuff like that. So when we get to the automation, we'll definitely talk about that a little bit more. A little bit about myself. Those who haven't seen this before, or haven't seen me here, or haven't taken one of my training classes, I am Ryan Cole. I'm with a company called Decide Solutions, and I'm one of the application engineers. Ultimately, I have about 21 years experience with the software. I started on in '95, about 2 months after it was released to the public, and I've been on it pretty steady since then. So I've done this most of my life, or about half my career, I guess. The other half of the career has actually been sitting in the hot seat just like you guys. So working with large assemblies. The last company I worked at, I was doing Class A diesel pusher RV chassis. So, we were dealing with 5,000 pieces or so. And, just having to work out there, done some robotics out there, done some custom automated machinery and stuff as well, too. So, take a little bit of pride on, having been where you guys have been and understanding what you guys have to go through and then trying to figure out better and, ways to do things is really what I like to do. So, to start that, basically what I want to bring across here is productivity inside of an assembly. I've done a couple of things like this. We've talked about how to make fast assemblies and stuff like that. I'll be reviewing some of the stuff that I've talked about previously, but I did want to bring something a little bit newer to the table as well too. So if you've been here before, maybe you'll walk away with a little bit more information than you have had before as well too. Key things I want to talk about here for assemblies in particular, the enter key. We're going to talk a little bit about that, what it does, what it can do for you, especially when you're inside of an assembly. The other one is tolerances in an assembly. And we're not talking about mechanical machine tolerances and putting parts together. We're actually talking about some internal items that inside of SolidWorks that some people, if not most people, are not aware of. And it may actually answer some questions, especially if you've ever ran into issues before. We'll talk about fixed components. This is something that I've been holding pretty near and dear. I've been doing it for about 3-4 years. Basically, I can get almost a 6,000 piece assembly. I can get it fully loaded within 2 minutes or so. If you've ever dealt with a 6,000 piece assembly with mates and everything on it, depending on your network load, your hard drive speed, you're looking anywhere from 20 minutes to an hour and a half. So the fact that I've gotten that down to 2 minutes, I want to kind of just reiterate that what I've seen before. I've got blog posts and videos on it as well too. The other thing we're going to talk about briefly here is smart components. So a show of hands, how many of you guys have ever dealt with smart components or ever heard of them? Has anybody ever heard of them? Okay, anybody ever deal with them? Yeah, so out of a group of what, 20 or so people, we had what, 5 people raise their hand that they've heard of them. Is it now those that have heard about it? Is that you have never had a need for it, or were you confused by it? Just haven't looked at it. Okay, all right, good deal. Well, I'll kind of show it to you guys. It'll show you what they are, and they're actually really nice. So, we'll get into it. Another key thing I wanted to get into, especially with productivity with assemblies, is what we call virtualization. With a show of hands, how many of you guys are actually using standardized items that you may order, specifically assemblies, like maybe like an air cylinder or hydraulic cylinder or any kind of machine, things that are multi-parts. We'll get into something that you can do with these as well too, and give you a little bit more functionality that you might not be aware of. Last thing we'll talk about, this is kind of the automation part, is the whole mate controller. How many of you guys are familiar with the mate controller? Have you guys heard of it before? No, okay. You guys ever try to like move a 6-axis robot around in SolidWorks? Yeah, that's always fun. Yeah, a couple chuckles, so who's done it. All right, so ultimately, getting faster in SolidWorks really isn't the key here. Really, it's understanding the information that you have, the capabilities that you have in the software. So we don't need the lumber going around going, yeah, that'd be really nice if you could use the software better. It's not that. It's just knowing that it's out there. And that goes back to that old adage that you only know what you know. So that's why these presentations are kind of beneficial. You sometimes learn something you never knew about before. Now, getting into it, the enter key. Is everybody familiar with the enter key? Yeah, it's on our keyboard. We use it all the time. I got a couple head shakes. No. All right. But mating on the fly, this is really what I'm going to get into. So if I come in and take a look at it, the enter key is your friend. It's really what it comes down to. One of the things I'll show you here, I'm going to go ahead and throw an assembly together real quick, but I'm going to show you how the enter key can actually help you mate parts together. How many guys are familiar with smart parts? I'm not smart parts. I just said that. Smart mates. There we go. all right, the Alt key, and you can snap drag, and that's pretty snazzy, right? But it has some inherent issues. What if you want two faces coincident to each other? Well, if you pick one face and drag it to another face, you still have to click something, and you still have to click OK, and you got to do this, and it kind of sucks as far as I'm concerned. I'm one of those people that I'm a little impatient. I got ADD. If I got to click 3 times where I could just go, whatever, just do it, that's what I want to happen there. So I'm going to jump over to SolidWorks here real quick, and we'll just take a look at an assembly. Actually, we'll just open an assembly. How's that sound? Oh, no. Somebody reset their computer this morning. It's not going to bode well for you guys. All right, so I am, if you've seen any of my other presentations, I'm a big Lego guy. I've been playing with them for a couple of years, developing them over the years, and they've actually helped me get faster and better at inside of an assembly and stuff like that. So I'm going to go ahead and just grab a part here. And part doesn't really matter, but the fact of the matter is that I have to mate these together. Now, if I take a look at Legos, Legos are pretty easy. I like them only because it's something that I can, refer to my younger daughter with, and she can start looking at how to build stuff and this and that. And even at your guys' level, it's one thing to bring up a widget on the screen, but you throw a Lego up on the screen, and everybody's like, "Oh, he's got Legos. That's kind of cool." So it's a tactic, all right. If you're in the surfacing thing, I don't have gum. I got Legos. There you go. All right, so really what it comes down to is I could go to my mate tool and I could click on it and I could click here and I could click here and that mates it up and I hit enter and then I click here and I click here and that's going to make it coincident and then I'm going to click here and then I'm going to click here and I would say that's a little repetitive, right? Yep, you can turn it off. It's in your options screen. So if you want to turn that transparency off, I am kind of on the fence whether I like it or not. I think the big problem I have is that I do like it, but I have to think a little bit more before I pick that first part. But yes, you can turn it off through options. All right, so I got that mated together, and that wasn't a big deal. It didn't take a long time, but one of the things you'll notice is I use the ability to guess what SolidWorks is going to do. If I pick 2 cylinders, SolidWorks is going to automatically try to make a cylindrical mate, and if I know it's going to do that, I can almost be ready with it with the Enter key. In fact, you can actually hit the right key immediately, and that's almost like the Enter key. Okay, so we have another way of doing this, and it would be with smart mates. And the smart mates are holding down your Alt key, grab a cylinder, bring it to here, say this. Because it's only one mate, I gotta go ahead and say OK, even though it's still cylindrical. And then I can do the same thing here, hold down the Alt key, and then I say OK, and then I bring this back up, and I click here and click here. Oh crap, I didn't do that right. So let's do this, and then we get to do the finger gymnastics. There we go. And then we finally say OK again. All right. It was a little bit quicker, but not really. Especially if you know that Enter key and you know that right-click button, that wasn't really that much faster. And when SmartMates came out, that's what we were, spouting about. Like, oh, they're so much faster. They are under certain circumstances, and really, it's a bolt in a hole. If you're putting a bolt in a hole, outstanding. They're awesome. Click drag, click drag, click drag. You're all done, right? All right. So last thing I'm going to show you here is I think this came in partially in 2015, and then 2016 is kind of spread it out a little bit more, made it a little bit more useful. And really what I'm talking about here is if I pick the 2 surfaces that I want to deal with, you're going to get your little fade in toolbar. Now, I wrote a blog recently talking about the fact that Ryan had to get out of the 90s and into the later 2000s because I was still using the old technology. Click a face, hit mate, hit OK, click a face, hit mate, hit OK. I was really quick at it. And, we get these new things, and I'm like, nah, I can do it faster my old way, which was amazingly enough is the same things that the old drafting guys were saying when AutoCAD came out, and the same AutoCAD guys were saying when 3D came out. So, I've kind of learned to like these. Now, what you'll see here, and it's kind of faint up there a little bit, but you'll see that it does have a little bit of a square around, a little dash square, and that says, hey, if you hit OK, or if you hit the button, this is going to give you cylindrical. So this is what I was talking about a little bit earlier, which is you kind of got to know what SolidWorks is going to do so that you can work with it, all right? So the reason I like it is because I don't even have to click it. In fact, if I click off of it, I'm going to hit these 2 surfaces again. What I have done is I turned one of my extra buttons on my mouse into the Enter key. So leaving my hand still on the mouse, I can click that button. Now that's concentric. I can click the 2 faces, hit Enter, click the 2 faces, and hit Enter. And now I've been able to put those mates in pretty quickly. So if you have one of those mice that has extra buttons on it, do whatever to try to get it on there. If you're using one of the pucks on the side, the 3D connection devices, there's an enter key on that or there's an extra button there. You're doing a lot of assemblies. I think this is a good way to go because it just makes it just one hand click, 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 and you're going through doing it really easy. All right? Yes. Yep. Yep, it's the only thing I got going over here on my left hand. So now the thing with the mates though is that if you were to be in the mate tool, and even the smart mates work like this as well too. If you pick two circular faces, you get concentric. If you pick two flat faces, you get coincident. And if you pick a concentric or a circular and a flat face, you get tangent. Those are your only three choices. When you click out of this, and I'm just going to go ahead and throw a couple of parts in here real quick, and I'm going to go ahead and fix this. Not fix it. Yeah, I'm going to fix it. That's right. All right. So I'm going to right click on it. I'm going to fix this down. And then I'm going to throw another one in here. This is really why I like this methodology. I'm going to click the four faces here because I want this third piece right here to be exactly in the middle. What mate would I use for that? The with mate, right? But I hate the with mate because you go to mates, you got to click out of it, and then you got to click the box, and you got to click the four faces, and then you got to remember which boxes went in where, then you got to hit OK, and then you got to click out of that stupid advanced mate tool, or else your other mates don't work, and you're confused, and you hit escape, and you go out and beat somebody. So we don't want to do that. Now, here's what I like. I'm not even in the mate tool. I selected four faces. It does not matter what you pick or how you pick it, but when you see it, that's the with mate right there. So I don't even have to get into the mate tool anymore. I just simply hit the right click on it. Don't move your mouse around. And then I can continue through here throwing the mates on. Now that's going to be fully defined, fully mated in. Yeah, it was about 9 button clicks on my mouse, but I did not go into any command. I didn't have to move my mouse. I didn't really have to do hardly anything. Everything was just very, very localized. Your enter key can be your biggest friend if you learn how to use it. All right. Yep. Yeah, if you're doing a smart mate, so you get two faces that go face to face as opposed to you want them facing the same direction or vice versa. One of the things that I've learned over the years to get around that is I will orient the part so that that's the obvious solution that SolidWorks can pick. That's what I always, and that, in fact, that's what I say in my training classes as well too. I'm like, just do it this way. It puts all the burden on the program. The other thing you can do is if you're using a smart mate, you can hit the tab key as well too. So if you're using a smart mate and you're dragging it over and it does a face to face and you don't want that, click the tab key. It'll flip it 180 degrees for you. So that'll come into play a little bit later as well. So you'll see that in action. I'll make sure I point that out. Um, No, no. The copy with mates has the specific button for alignment. So there is a if you do the copy with mates, there is a box where it says default, which is it's going to pick whatever's closest to it, or you can actually say align or anti-aligned on there. And I think there's a fourth function that I look at and I'm like, whatever. It doesn't make sense why that fourth function is there. So yeah, they can sometimes turn. Yeah, yeah. So the smart mates, no, sorry. Yeah, no, smart mates. I'm thinking reference, mate references has that option. I don't know. I'll have to look into it. Something that I can look into. So as far as doing the mates, I like that little pop-up now. I didn't like it at first, especially because my first reaction is to go to the feature manager. So I always like make it disappear, and then SolidWorks made it like, oh, you got too far away. So it is something that I've been trying to change. I'm not always perfect at it, but I have noticed that there was a marked increase in my assembly speed as well too. So definitely something to try. All right, mate tolerance. Tolerance. Not all is perfect as we think it should be. All right. I'm going to ask a generalized question here. Have you guys ever tried it? You're working on a fairly decent sized assembly, maybe 20, 30, 40 pieces. You go to put a mate on, and SolidWorks just goes, nope, not going to do it. And you're looking at it, and you're like, it says, oh, I can't make that coincident. But you measure the distance, and it doesn't come out to 0. It comes out parallel. All indications are that down to 9 decimal places, that's exactly where it needs to be. But SolidWorks is kind of talking a little bit on it. So show of hands, have any of you guys run into something like that? So a significant portion of the, everybody out here has ran into it. More than likely, there's two reasons for this. One reason is how many of you guys are using flexible subassemblies? No one. All right. That's kind of, well, sometimes, yeah. You like them? Yeah? Did, when they work, thank you. That's, you were going to get to the water, man. So, yeah, that's the thing. And it is, yep, yeah, yep. Yeah, yeah, definitely. One of the other things that I run into is that if you have a flexible subassembly and then you have a new washer, you just brought a new washer, new part, you try to make it concentric with a hole, it goes, nope, can't do it. And you're like, why? Like it's the very first made on a part. Chances are you got to just turn the flexible assembly, subassembly, make it rigid, make your mate, turn it back to flexible. It's kind of weird like that. The other thing I've run into, and you've probably run into it if you use them a lot, you're working along for days and days on your assembly, everything's great, and then all of a sudden one time you do a rebuild, everything's red, and you're like, I have no idea what's going on. So you close it down, you open it back up, everything's fine, you don't trust it anymore, but it's okay. Um, and then so you'll find out that it's this flexible subassembly. So they are bad, but there's some weird things in the background, and I'm not going to say the function's bad. I think it's how the data is being handled in the background. I think it confuses itself more than anything. So, worst case scenario, make it a fixed again, bring it back out, and you're going to be all good to go with it. So keep that in mind next time. So what I'm really going to talk about here, though, is the mate tolerances. And this is something that we run into. And if you ever run into it, you kind of want to sit back and look at everything. Just kind of think about it, what's going on here. Now, as demonstrated up here, I've got a Lego, and I'm going to make that Lego to another Lego, and that's going to be mated to this one, and that's mated to this one, and that's mated to this one, and so on, and so on, and so on, and so on. But then when I get all the way over here, I want to make this coincident to the bottom here, and this coincident to the top there. Well, technically, it's the same damn part. There should be no problems with this. But you go to put that last mate in, and SolidWorks goes, nope, can't do it. And you look into it, you look at the problems, everything says, well, I can't go to 0 because I'm at 0. And it's like, yeah, that's what I want. That's what you should be, right? So what I've noticed is that there's some, like, we go down 8 decimal places, but I think there's math beyond that point happening. And I think it's only displaying 8 points, but I think it might be going down to 12 decimal places. And I think there's a little shift of number way, way, way down there. The other place that you're going to run into this is if you're running metric numbers with inch numbers as well too. So even if you take it and I say, oh, that needs to be 4 millimeters, but if you're working in the inches, I think there's something that happens there. It's one of those things that it's one of those things that I finally figured out, like, oh, I've got this cyclic thing. I ran into it just recently, so it's not like I've ever figured out how to get around it. It's one of those things that when you get to that point, you hook or crook it. You just get it done however you need to get it done. I've had to come up with some, like, this point on this face, and that works out fine. You know what? That's good. I'll just let it go, and then I'll go kick some squirrels or something after work or something like that. All right? So keep it in mind, you don't want these big loops. Now, like 4 parts together, that's usually okay. It's really when I see multiple parts, part on top of part, on top of part, and then you try to connect them together and they should work. Yeah, that's the thing you're going to run into. So nothing to really demonstrate there. I'm always surprised when I get it. In fact, I grit my teeth for about 15 minutes before I realize it's this situation I'm in. So it's real hard to demonstrate, but hopefully you guys can have an eye out for it. And truly, this is what you do when it happens. Whatever, get it done, move around it. You're not going to get what you want. That's really what it comes down to. All right. I'm a tech support guy, can you tell? Let's see here. Fixed components. More review than anything. This is something that I've talked about over a couple of years now. It's as far as how to make an assembly faster, open up better, open up quicker, and stuff like that. And what it really comes down to is I like to use a lot of fixed components inside of my assemblies. In fact, as a quick item here, oh, I didn't shut down. Yay. I'll open up one of the larger assemblies I have here. So, if I were to tell you guys, hey, I've got this 6,000 piece assembly I want to open up and show you, and then we're going to do it live during a presentation, that sounds like a presentation killer. In fact, it's going to take me probably longer to find out where the damn thing is here. So let's see, Legos and Millennium. There we go. If you've seen this before, be quiet. So I have 5,600 pieces individual Legos put together in assemblies and sub-assemblies and all that good stuff. We're running about 17,000 mates because when I made them in, I don't do the lock rotation or anything like that. So we're looking at about 100 hours worth of work. And before you guys say, well, he's got a lot of free time. No, I was on tech support when I did this, so I got paid to do this. So then I recorded it. We'll let my boss listen to this one day. So everything was fully mated together. If it didn't move, it didn't move. If it could move, I had the mate set up appropriately. Like you got a little ramp there on the side that can go up and down and all these little, kinematic functions to it. And really what I'm doing is I'm trying to eat up some time on the clock here, and I'm waiting for a little shift in the graphics in the background. Right now we're looking at the dirty graphics. Did you see the shift just now? Once that shift happens, the data has been fully loaded. Now, if you guys have been using SOLIDWORKS for a little bit, or you've taken the Advanced Assemblies course, you hear about lightweight parts and large assembly mode and all this stuff. I've turned those all off. Actually, I should shut up because I just reset my computer. Dang it. All right, let's load all the stuff here. So we're going to right click and set lightweight to resolve. This will take another half a second here. Minute, maybe. So the real gig here is even with these lightweight, 2 minutes is still pretty good. I mean, even with large assemblies, I've had to wait around for 20, 25 minutes for a large assembly being loaded lightweight to come up on the screen. So we'll let the little disc spin around a little bit more. And any ideas how I'm doing this? None? So what I've done is this, and now that I've completely hosed myself here, this is way more impressive in my head, just to let you guys know. One of the things that I've done here is that there's kind of two modes of thinking, especially when you start dealing with large assemblies. You can bring the parts in, put them where they're supposed to be, and tell them to stay there by fixing them in space, and then you can get rid of all your mates. Don't do that. The other way is bring them in, mate them in, but then fix them in space. Now, the cool part is, and I don't know when SOLIDWORKS did this, it was around 2012, 2011. They made it so if you fix a component with mates on it, it would suppress the mates on the part. Previously, it would blow the mates up because it was over-defined at that time. So basically what they're doing here is they're kind of saying, okay, since you have mates on here and you're fixed, we're going to suppress your mates for you. That actually ends up being really, really nice. Now, there's a little bit of a downside. Can anybody see the downside of fixing a bunch of components in an assembly? We got one nut. They're not going to move, right? What if I do an update to a part? What's that going to do to my assembly? No, it does nothing, right? It doesn't even go to air, right? Because I got two parts that are fixed in space. So if a hole misaligns because there was a concentric mate on it, well, it's suppressed, so it never goes bad. So therefore, now that's kind of a big killer. So here's the deal. I work on ratios is really what it comes down to. Aside of what I'm showing you guys here, because now I'm getting a little perturbed, usually I can, and I just tested this the other day, sorry. So it takes about 1 minute and 48 seconds to open this up if it's fully loaded. Why it's taking so long now, I haven't figured out. The thing here is that I've worked on assemblies that were similar in size, and those are taking 40 minutes, an hour and a half. I had a 2 hour and 15-minute load time on one of my assemblies just because of the size of it and the data that was in it. I opened that up twice in one day. I mean, literally half my day was sitting there watching this file open up. So when it gets down to it, there's a couple of things that you need to know about. Well, first off, I used to think that the whole fix thing was junk. I was one of those purists that like, no, leave all your mates and stuff in there. But, then I kind of grumble about the fact that they're opening their stuff up. But when used correctly, it is kind of a little bit of a piece of work and art. So you can take that file, that fixed component, and you can turn it into something that's usable. Well, how do you make it usable? Well, if you make a change to a part, here's the downside. You're going to have to go ahead and it's junk food art, not junk art. Sorry. Oh, thank you. Let's not rebuild. There we go. So sorry, guys. I want to look at it here. You'll see that the parts are fixed in here. All of them are fixed. And then if I come down here to my mates, and these aren't all the mates because I am using sub-assemblies, you'll see there's actually quite a few mates. In fact, if I get to the bottom here, you'll see that that is coincident 1,206,456. All right. So why I got that high, I don't know. I didn't do 1 million mates. Maybe I did. I don't know. I wasn't paying attention. So, So really what it comes down to is there's a little bit of onus on me. It means that if I make a change to my component or a component, I am going to have to take time to go to my assembly and I am going to have to manually update it as opposed to letting SolidWorks update it. So here's how it works out. I can take 5 minutes and put that extra bit of work into it because I know where to go and what to float. And that's really what you have to do. You have to right click on the part, float the part, let the mates reevaluate, and then right click and fix the part. That's really the whole thing that you have to do. Now, if you change 18 parts, you got to do that 18 times. Make sense? All right, so let's say that's taken 2 minutes per part per change. All right, so now we're up to what, 36 minutes of work that I've done in there? All right, if I open this up, and I've tried it one time, and I got to about an hour and 10 minutes, and I gave up, and I just shut down SolidWorks. So I've never actually loaded this fully resolved, but I know it takes longer than an hour. So do I spend that 1 hour opening this up full weight with the mates calculating, or do I take the 36 minutes, whatever, to go through and manually make the change? Does that kind of make sense? All right, and then think about it. If I open it up twice in a day, that's 2 hours, and I may only have to make one extra change. So now it's 2 hours compared to, 38 minutes worth of work. So if you'd use this functionality, the best thing I can tell you is, let's see, don't fix moving parts. Oh yeah, no. Yeah, if you had like a group of parts that are all together, you could right click, you could pick them with the control key or the shift key, right click, float them. They'll all go. They'll actually update immediately, and then as soon as they update, you can pick them all again, right click, flip, fix, and you're all set. I think it was in 2013 because that's when I actually generated this particular piece. Yeah, yeah. It does shorten your rebuild time. In fact, that's what I'm skipping over is the rebuild of all the mates. So it does definitely do that. It does not really do anything for your file size because that's not something it's still storing the mates. It doesn't reduce your file size, but it does reduce the rebuild time definitely. You guys have to take it out to the parking lot and figure out whose way gets to be done. Oh, the feature freeze. I'm sorry. I thought you said the fix. I apologize. Yeah, the feature freeze. He can roll the bar up and down. So, yep. Yeah, I think it's going to be similar to the opening lightweight. Like if you open up something lightweight and he doesn't have lightweight turned on, he's going to open it up fully loaded. You're going to open it up lightweight. The freeze bar works the same way. If you open it up on your computer, you have your freeze bar turned on, it's going to be frozen. If he opens it on his computer, it's not going to act as if it's there. So it doesn't do anything between you two guys as far as that's concerned. It shouldn't do anything. Not the assemblies, no. No, yeah, that'd be nice, but unfortunately, no. Anything that's going to have to move has to be floated. So if you move a hole, the part that's going to move has to be floated so that it can update it and adjust it. So there's a little bit of thinking. That's the downside. There is a little bit of thinking, but once again, if I'm saving an hour or two a day by doing it this way, then I can spend an extra 45 minutes doing extra work there. So main things to remember if you're going to do this kind of methodology, it is a methodology. Don't fix moving parts. So you can have parts that still move around. I have them in that big assembly there. You do spend more time updating the assembly. I'm not going to lie about it. I had one customer go through and do it. I come back a couple months later, like, yeah, we tried that. We didn't like it because we had to update the parts manually. And I'm like, I told you that in the beginning, right? Um, but the thing is that you spend time waiting for it to open. In fact, you are working less at that point. You're looking worse, just sitting there going, just waiting. You're reading magazines, whatever. It is time spent updating an assembly more. Basically, is the time spent updating the assembly more or less than your opening time? That's really what you want to use there. And if it's less time, you're being efficient. It may not seem like you're efficient because it seems like you're doing extra work, but you're being efficient at that point. If it takes less or more time to do this than it does opening it, you probably have a really small assembly. Don't do this with small assemblies. I'm talking a couple thousand pieces and above, or depending on your computer. So if you're working with a 50-piece assembly, I don't even mess with the whole fixed components. It's only on really large items that I start really looking at this. Fair enough? Fixed components can be captured with configurations. It's something I wasn't aware of until probably about 10 months ago. Scholars called me up, I did a blog, and they're like, hey, did you know you could configure that? The fixed component is actually configurable. So I haven't tried it, but what I'm wondering is that whole thing where I said you have to float a component and then fix a component. I'm wondering if I can actually have a configuration where I say float everything, let it update, and then fix everything. It's going to take an hour or two, but maybe it's one of those things where I do a bunch of changes, let it kick off for an hour. That's still better than sitting there waiting for an hour for it to open up every single time. Kind of make sense? All right, and be careful of the logic loops, especially here, because I have hundreds of components all intermingled with each other. I think one of the things that I'm running into with the long load times is that I'm getting this error, and you guys have seen it as well too. You're working on assembly, you do that one wrong mate, you wanted it concentric, made it tangent, and then you get to sit there and SolidWorks punishes you while it's sitting there, and you're like, come on, I know I did it wrong, let me fix it. Be careful of these. These will come and bite you here because you don't see them right away. So keep that in mind with those cyclic redundancies. Smart components. Um, this is really a time up front. How many guys deal with standardized parts on a regular basis or standardized assemblies? Let's say assemblies specifically. A couple of you guys here and there. How many guys are doing machines? Automated machines? Okay, guys, are you buying stuff from like catalogs and stuff like that? Okay, so this is where it kind of comes into play a little bit. Making those components smart. How do you do that? What can it do? I'm just really going to hit the top of it at this point. It can go really, really deep, and really what it comes down to is it's library features. That's really what it comes down to. So let me jump over into here. Shut this down. No, I don't want to save. And let's see, assemblies, smart components, and there we go. So I got a test. There we go. So basically, what I want to do is I'm going to bring two parts together. Default, and really, it comes down pretty easy. I mean, I can sit there and grab this edge. I can drag it, snap it. That's our smart mates working for us, especially with that concentric coincident type of operation that's going here. So I like this. That works out good. But the thing is it's the wrong size. In fact, what I really did here was I didn't put it in the right place. It should have been here. It should have been this edge to this outer edge. And then I'd have to come in and I go to my configurations and I'd figure out which one works. We can see if SolidWorks crashes. It's always good during a presentation, right? Oh, there it is. In case you guys don't think it happens to tech people, it does. I just don't get angry and call somebody up. Yeah, there you go. I always love those. All right, let's try this all again. The work message is when I get an error, it says call your tech support representative. I am. All right. Now we do have some mate references in here. They have a mate reference on the inside. So they went ahead and went through into that. The thing I have here though is I do have my different configurations available here. All right. And this is what I really don't want to manage. What I want to do is I want this whole smart mate thing to work for me where you drag, drop it in, and I feel great about myself. But especially with my Legos, I run into this quite a bit. I drag a part in, I drop it in, I made it in, and then I got to make sure I have the right size in there. So I got to right click, change config, da 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 da. Smart components are actually pretty cool. They actually can do quite a few things. One of the things they can do is they can use mate references. So a regular part can do that. What makes it so smart? Well, the smart part comes in is if it has configuration capabilities, or has configurations in it, you can actually have it auto size itself depending on the situation it comes into. Like in a case like this, if I were to say open up this pipe here, I've got 4 different sizes of pipes, right? And if I come in here and take a look at, in fact, I've got one that's already prepped up here. Imagine that. If I take this, here's my part, and if I drag it over the parts, you'll see that it automatically resizes itself depending on where I drag and drop it. Now, we talked about this a little bit earlier. How do you flip a component? Well, I haven't let go of the part yet. That's going to be key here. If I hit the tab key, it'll flip the direction on it at that point. All right. So now I can quickly come around, drag and drop that, say OK to that, hit tab. Come on, there you go. You got to do the funny wiggle to it. Sorry. No, it has the configure. You have to have the configurations there for it. All right. So there's a little bit of thinking that you got to get into. So that's one of the things it can do. It can do this auto sizing, and it's pretty straightforward. One of the other things it can do is that this is a single part that's being auto sized. You can do this with assemblies as well too. You can have a part with configurations and an assembly with configurations, and it will automatically update depending on what it hits. So not only will it do with parts, it will do it with assemblies. On top of that, you can actually have features in here as well too. So if I had, say, an O-ring, I could drag the O-ring on. Not only would it resize itself, but when I dropped it where it needed to be, it would then cut the groove in for itself as well too. So I don't have to pre-cut the groove, then bring the thing in, then resize it, then mate it. I can actually have it do it automatically. All right. So it's a very specific set, highly standardized components to use. You're not going to do this on some component that you're going to use in different places and be done. It's going to be the very highly used standardized parts. That make sense? Now, I will show you real quick kind of how it works out. It's not too awful bad. Ultimately, what you do is I'll start out with an assembly here, and I'll bring the part in, and this is my original part here, so just go ahead and bring that in. And I really don't care about the size either, so I'll rotate that around. I will mate it into position here, just so it knows what it's looking for. Windows key is not the same as the Alt key, just let you guys know. This is my little secret of the day. No, okay, whatever. That's good. And then to make it a smart part, here's the stuff that you go through. So I'm going to come in, go to Tools, go to the Create or Make Smart Part component. It's going to ask you what component you want to do. You're going to pick the main component that's going to change the smart component of it. If you had other components, say screws or a sensor in this particular case, this is where you could kind of put it in and make it work correctly. This is where you would add other components in here. And then underneath it, you would have features as well too. So any feature that you had that you wanted to come along with it, you could put those in there. So you can have this all loaded up, resize, add parts, add features, everything, just with a simple drag and drop and release. All right. Now, I do have, I need to come in here and say that I'm working with a diameter, and I'm going to put inside face. And the only other thing I'm going to do here is I'm going to hit the configurator table. This is where you put the little bit of tolerancing that's going to be in there. All right. I don't know that all my pipes are going to be the same size, depending on who made them, when they made them, what they looked at to make them, or anything. So I do have the separate configurations that are already available. And then what I'm going to do is I'm going to simply fill out the information above. So I'm going to say that a 1-inch one will fit between a 1.3 diameter and a 1.4. The half-inch diameter will work with a 0.8. I don't know what these, I think it's half-inch, but we'll see. So it's 0.8 to 0.9. And, unlike our coincident mates, this is the fuzz factor. We're actually adding a tolerance saying it's okay to work between 0.8 and 0.9. And if it falls between this range, this is the configuration you want to use. All right. So you continue to fill it out. We'll say 1 to 1.1. We'll do this one at 0.6 to 0.7. And then we'll finish that one at 0.8 to 0.9. And we'll say OK. And we'll say OK one last time. And we basically created a smart component. You know it's a smart component because if you look over here, it's a little hard to see in the back there. But right next to it, you're going to go ahead and see a little lightning bolt next to it. That means that it is a smart component. The last thing you need to know is you have to put this in the library. So I made the mistake of putting this on my hard drive and thinking I could drag and drop it in. It does not work that way. You can see up here at the top, it has a smart feature. If you need to modify it, add features, change that table, do whatever, it's all here for you. If you want to add configuration, you can do it. It does work like a normal part. The last step you need to do is drag it, drop it into whatever folder location you want in your library, and then you can give it a name, say okay. Now that part is now usable as a smart component. All right. It takes a little bit of upfront thinking to make sure that you have all the cases covered and like, well, if I drag this O-ring to this size, it should be this size. You kind of got to have that in there. If you're ordering O-rings from a catalog, most of that information is all there for you. You can just really just kind of reinstate it into that little dialog box I showed you. Fair enough? Kind of cool? How many guys have uses that you could use this for currently? Just one person? People, maybe? All right. That particular part? Yeah. Saving to the library, yes, sir. Yep. Yeah, yep. Yeah, put it in your library and then drag it in. So yeah, most definitely. And these are like really for parts, catalog bot parts, website, sit. Yeah, because I didn't care. That was just used to set up my mates and my references. So it could have been a little pencil lead in there, and I don't care. It was just that concentricity I was looking for. I don't need to save it in the library. No, well, just the part. I didn't save the assembly into the library. Yep, and you can chuck the assembly away. Because it's upon insertion. If you right click on it, you can make it upgrade or update it, but I haven't gotten that to work successfully. So it's one of those things that if it didn't update and I want to see it update, yes. Yeah, you're not going to do this on the fly. This is an upfront thing. This is like, hey, we've got this part that we're going to use a lot of, O-rings. We're going to go ahead and set this part up. You're going to come up with a dummy assembly, a dummy shaft, everything. Uh-huh. Okay. That you should be able to right click on it and tell it to update, but you have to do it as a manual update. It will not update automatically. Yeah. Yeah. Which is, I mean, pick it, delete it, drag, drop it, walk away. I mean, so if that's the worst case scenario, it should update, but it's still a right click and you have to click a button to update it. So, all right. Virtualization. How many guys are familiar with virtual components? Show hands. Crickets. What do you use do you use them? Okay. Right. Okay. All right. So virtualization. It's got so many uses. This is just one of the uses that you can use it for. This is, it does. No, it's not. Shh, be quiet. All right. So no, I don't. No, something's not right. All right. All right. I will say I've used virtual components for about 6 years. So, all right. All right. No, I know. Yeah. So we're going to be quiet. I'm going to be quiet. Um, so virtualization, not virtual reality. Really what it comes down to, virtualization is a way for you to store information internal to an assembly as opposed to having it go to a file. How many guys have ever sent or gotten, I'll say got, because if I say sent, that means you did something wrong. How many guys have gotten an assembly file from a coworker or somebody else and you're like, hey, give me that assembly. And they send you the assembly and you open it up and what do you got? Nothing, right? And you call them up and you're like, I need the 500 parts that go along with this. And they're like, oh, I didn't know that. You are looking at the preview data that is stored. In fact, that is the biggest part of an assembly file, is this 3D preview that you see. It's the same reason that you have a part that's updated. So when you open up the assembly, you zoom into the part, it's not right. And then all of a sudden it goes click, and then it turns into the right part. You're looking at the saved virtual 3D data that's in there. So if you zoom into it really close, you'll see that it's very triangulated. It's very ugly. If you use the large, the large design mode where you can open it up almost instantaneously, that's the same data that you're looking at there. That's why they say if you go to measuring it, you get the big message of going, look, if you measure, things might be off. And that's because you're not dealing with a true circle anywhere. You're dealing with a bunch of triangles, and they're just guessing for you. So that's kind of what you're looking at. That's why it does disappear. Same thing happens with drawings as well too. You're looking at the preview data. As soon as it realizes that there's no parts or assembly, boom, you got a bunch of blank views. So it's kind of that common thread that we have in there. Now, I'm going to be very specific here. There are some issues, so I'm not going to discount the crowd out here. There are some issues that you can run into, but this particular one, I haven't run into too many. I've used it for quite some time. So if you're having issues, I would say definitely call the tech support. Oh, it's 2013. It's come night and day since then. I know what you're talking about, so sorry. Um, so virtualization, it's kind of cool. Really what it comes down to is this. I'm going to open up an assembly here. Lo and behold, you'll never guess, it's a Lego. Now, right now I have this assembly, and it is pointing back to my Lego library at this particular point in time. And I am going to upload these files, so technically you're going to get some of my Lego files. Just don't put them out there as your own. That's all I ask. So if you come in here, let's go SolidWorks. It's pretty exciting, isn't it? No, it's stupid. There we go. So if I look through here, I've got all my components sitting there, all nice and pretty and stuff like that. Now, if I go down a little bit farther and look at my subassemblies, you'll see that there is a square bracket around them, and they do have a little caret symbol with the name of the assembly in there. That's a virtual subassembly. In fact, what it is do you see all those subassemblies right there? They don't exist. They don't exist as a particular file on my hard drive at this particular time. They're actually stored inside of this assembly itself. All right. Now, to make something virtualized, there's a couple different ways to do it. But what I'm going to do is I'm going to segregate the rest of these part files away from the original part files. What I'm going to do is I'm going to take the data and store it internally. So I'm going to pick all the parts, I'm going to right click on it, and I'm going to hit make virtual. It's going to go through, and then it's going to blink. And if you take a look at my feature manager, you'll see it update here in a second, one day. This is going to go ahead and turn all those, it basically disconnected everything. So what I can do now is I can take this assembly and I can email it to you, and you can open it up, and all the parts and everything will be inside of it. Does that make sense? Kind of like a zip. Yeah, I'm storing it internally, yes. Now, kind of like a belt and chain, yeah. In fact, if you guys have if you've been in 15 and 16 and even 14, if you've created a new component, you created a virtual component right then and there, all right? So as far as the virtualization, we are disconnecting it. I think zip the files into the assembly. That's a great way to put it. You're not compressing anything. You're just kind of storing it in there. It reduces the assemblies to only one file, so that's kind of nice. Yes, the file size does get larger, but here's the argument that I've gotten into. Where I used this was when I would go to Bimba and get an air cylinder and download it. It's the most beautiful air cylinder you could get. It's awesome. It's great. It's got all the wipers and the rings and the bolts and the nuts, everything I don't care about. And what I hated about it was that it was the one assembly I need and these 30 other freaking parts that I don't care about, but I had to now manage them. I had to store them. I had to make sure they were there. And then you get another air cylinder that's kind of similar, but then now the parts interact with each other. Yeah, and it's just like, oh, are you crazy? You know, this is crazy. Now, what I had to do at the time, this was back in 2007, you didn't really have this capability, the virtualization. You had to do a right click, save the assembly as a part, but I hate that because now the air cylinder doesn't work. And then you go like, oh no, we can use configurations. I like to see things moving, not closed, open. I don't like that, right? So this was kind of nice. I like using this because it is an assembly. Everything works in it like an assembly. Everything works. Your mates work. Everything. So if you like configurations, add configurations. You want to do the flexible subassemblies, do flexible subassemblies. Everything works. There is one downside to it, and I'll show it to you here in a second. As far as the file sizes, think about it. If you open an assembly, and I sometimes get this when I'm talking to people, they're like, "Well, I don't like to keep parts open because I want to reduce the amount of memory I'm using." If it's on the screen, it's loaded into memory. You closing it does nothing to your memory whatsoever. So if you take a look at it, the file got as big as the assembly and all the parts. If you added them together, that's how big the assembly got into. So you're not utilizing any more memory than you would have before. The same amount is being stored in there, except you don't have these external references anymore. So your CPU time and your calculations actually go down a little bit. So it doesn't make it super fast, but there's like a 0.01% improvement on it. So not enough to sneeze at that point. There are downsides, and I'll show you one of these downsides right now. Here is a virtual component. I'm going to open it up, and lo and behold, this is a part that had configurations in it. I can flip the configurations out to whatever I need. I can come in here and add features. Nothing is locked out to me. Everything works except one item. Does anybody know what that item is? Do you know what that item is? No? Actually, a save saves the assembly. All right, here it is. File, make drawing. You can't make a drawing of a virtual component. Now, if I'm at the assembly level, I can make a drawing of an assembly with virtual components in it. That make sense? That's the only downside that I've seen. Well, not downside, but that's the only thing that I've seen that you can't do. You can't create a drawing of a virtual component. You have to make it a real component, and it's as simple as doing this. You right click on it, and you say, where is it? Oh, save part in external file. There you go. Uh-oh, here it comes. Yep, compiling. Yep. You can save it wherever. Yeah, their drive. Yep. It's still, well, if you save it external, it'll save that part, it'll create a brand new part file and connect it up to the file in here. So it does go both ways. So this is one way to use it. I used to use it for hoses. Hoses are flexible. So I'd use flexible, so I'm sorry, I would use virtual hoses in my assemblies only because we did have one file that was a hose and it had 300 configurations for 300 different chassis. So yeah, about every other day we were fixing that file because it was blowing everything up. The virtualization, cut it from the outside file, always worked internally. We didn't have any more headaches after it. So yes, sir. It's almost like a save as. So it keeps everything. Yeah, I've not found, except for the drawing thing, I have not found anything that gets. No, no, because these are real parts. If I come in here, yep, these, yeah, these have design tables. They have everything in them. If I did a save external, everything would come through, just like I did a save as on a part. So. It's usually a stability issue, but even back then, the only thing that I ran into issues with the virtualization was PDM system didn't like working with them. That's changed today. Yeah, and our team's not set up to even recognize them. Yeah, yeah, yep, yep, yeah. That I haven't seen. Yeah, and that would be something to look into. So, I mean, have you talked to Ford at all on that kind of stuff? Yeah. Yeah. I can't explain it. Right. Right. Yeah. I don't know. Yeah. Yep. Yeah. I'm unaware of that. So. Yeah, no, that does sound bad, so I won't disagree with that. I haven't personally seen that, so I've been using them pretty regularly for. Yeah, yeah, yep, right. Yeah, yeah, and I'm wondering how much that has to do with that. So yeah, okay, something happened. Okay, maybe that's what I have to make it to survive. Yeah, with that, make your computer survive, right? So there are a couple downsides, as we can see, and I'm wondering how version specific it is. So it might be off this today. I know, like I personally haven't run into issues with it at this point. Used for imported or standardized assembly. So if you get that assembly from, say, your tier one supplier, GM or something like that, just throw it all into one assembly. It's going to work out good. It will definitely be smaller than if you do a save as part. How many of you guys are familiar with the saving assembly as parts? Problem that you run into there is that if I have a screw and I have 300 screws, I have to store the body information for 300 screws. This still uses an assembly. So if it sees one screw and it sees it 300 times, it only loads and stores the one screw. Does that make sense? Yeah. Yeah, because eDrawings is looking at and even eDrawings is looking at that reference, that stored geometry. It's not looking at the actual part. That's the same thing that we have with the measuring inside of eDrawings as well. So yeah, it can see it just as well. Make controller. My wife would like one of these. Six-axis robots suck. So, have you guys ever had to deal? I think we had one hand come up. Anybody else had to deal with the six-axis robot? You guys ever have a couple motion capabilities? You got a linkage to a linkage to a linkage. You get three parts linked together, and you try to move it around, and it starts flailing around, and you can't do anything right. Or it's working good until you look away and you look back, and then it's all over the place. All right. So we have the Make controller, and show of hands, how many of you guys are familiar or have heard of the Make controller? Yes, one person. That's about it. You don't know it either? No, you wouldn't because you're in 2013, man. Yeah, it's something that's new. It came out in I think it was 2016. We updated it in 2017. Does a little bit more. I'll tell you what those are. What is it? Why is it? And how is it? So, the what is it is this: is if you've ever had an assembly that has multiple points of motion, you could throw a bunch of mates on there, and that just makes it all stiff. And then you could move one thing at a time, and right click edit or double click, and it's ugly, right? The Make controller allows you to move stuff a little bit better and a little bit more controllable, and I'll show you how that works here. Why is it in there? Well, go back to it. Six-axis robots suck. The amount of times I've tried to animate a six-axis robot, especially coming from Panic Robotics, is just inordinate. It's just such a frustrating thing. I go and talk to people, and they're like, "Oh, we got these robots. I want to show my customer them all moving around," and I'm like, "Yeah, okay." And we tell them how to do it, and then they call us up. They're like, "This sucks," and I'm like, "Didn't I tell you that when I told you?" So and it's pretty hard to say it sucks, but it does. Really, it's the way that SolidWorks calculates the kinematics in the background. They use a forward kinematic as opposed to a backward kinematics, and that's what really gets us into problems. And you can tell how nerdy I am because I read about this. And then really how it is. So let's get in there and we'll controller. There we go. So talking about a robot here, and it is a 6-axis robot. All the axes are there. In fact, what I'm going to do is I'm going to right click and suppress all the make controllers. So what I have here, and we're going to be very tentative because when we move a robot around, we don't want to move a lot. Well, already we can see things like look at the arrow at the top. See how it's already spinning around on it? I'm not even touching that. Why is that moving, right? If I grab up here, we can see that it's kind of acting right. If I grab this, that seems to be working better. Well, that's the way I wanted it to work, but now it's not rotating around anymore. But really what it comes down to is that trying to get this to act right is short of just heroic trying to get things to work. So, usually what you get is you try to drag this to the other side, and then you get this flippy motion. I didn't want that. I wanted it like right here. Oh, yeah, right there. No, that's not what I want. And then you move this a little bit, and then it starts doing that. It's frustrating. And you chase it around, I'm not joking. I work out of my house. I go in the backyard and I kick woodland creatures. So I'm going to go ahead and stiffen this back up. What I have is a couple mates in here, and these mates were specifically to control the different angles here. Now I just did some rearranging, and this is the way I used to do it. Here's joint 1, joint 2, joint 3, joint 4, joint 6. Okay, so I need joint 1 at 45 degrees. Right click, edit it, 45, rebuild, because you never know if it's going to go one way or the other, right? And then so we're like, oh great, okay, so it's going the right way. So then I say, okay, I get out of it, right click the next mate, move that to 180 degrees. Well, then it's just this rigmarole that you go through. And then it's one thing just to make this into position, but a lot of times we're trying to show a customer how the robot's going to move, and we want them to see this motion. So you're like, haha, I'm going to use the animation package. Doesn't work, because then all these little things that I have to worry about, I'm just tossing them over the wall and say, here, you figure it out. We've already seen how SolidWorks figures it out. Starts flopping it all over the place, and it's like, that's nothing what I'm looking for. Now, what the make controller does is it allows me to control this a little bit nicer. So I'm going to go to Insert, Make Controller, and it's going to pop up. Now, the first thing I have to do is I have to tell it the mates that I want to work with. Specifically, it's all those ones I named specifically. So I'm going to come over here, and instead of picking them, I'm just going to tell SolidWorks to come up with a list for me and say, hey, any mate that can be controlled in here, a distance mate, an angle mate, I want it to be shown in here. So I don't need this distance mate here because it happens to be down here. So I'm going to right click and delete it. And then what I can do is I can see here that it actually put them in order as well too, J1, J2, J3. So this is the 0 position I have it at. If I move it to 45 millimeters, you can see it moves it over to 45 millimeters because everything else is mated in. I don't get that funny kind of wishy-washy things move it around. The other thing I don't have is I'm not getting into the mate, making the change, saying okay, getting out of the mate, and going through. So it basically allows me to edit all 6 of these mates together at one time. So I could move this to 45, I could change this to 90, I could change the next joint to say 90 as well too, and then I can take the wrist and take it to 0. And then I can actually save this as well too. So what I'm going to do here is let's go ahead and cancel out here. I forgot one step. Let's go ahead and rebuild. Rebuild's going to take it right back. So insert mate controllers, grab those mates. Now I'm going to say that this is position number 1. I'm going to add in a position number 2, and you'll get a little drop down list here. Position 1, position 2 here. So I'm in position 2. I'm going to make those changes that I did. So I'm going to put in a half step here, 45, 90. We'll bring that up to 90. And then we'll bring this down to 0. And then we're going to say update this position. We're going to add a new position, call it position 3. And then we're going to take this to 90 degrees. We'll take this to 135. And then we'll take this to 45. Or even 135. Let's do that. And then we'll add this in. And then we'll go ahead and add in a 4th position. And you just keep on adding these positions, position after position. And the key benefit we have down here is that we can come down to the bottom here where it says animate, and then we can actually see those animations come through. So we're actually storing those as they come around. Now, that's nice in itself, but it was almost useless for most users. It made a great animation, made it easier to animate it. The downside that you really couldn't save it outside of the animation. Like, created a great animation, but what if I wanted to show this in my actual machine? New to 2017, it allows you to save these off as configuration. So it would be configuration position 1, position 2, position 3. So now I could actually click through them and make it a little bit nicer. All right. So they took something that's kind of cool and useful for animations and then made it so it's cool and useful for everybody else in normal day life. All right. So kind of see that though. I've got the completed one here. And if I come down here, this one was a little bit more thought out, but I've got a couple positions. I even put some dwell points in here as well too, so it'd hover at a point. Basically, I took a step, said you're gonna hold for a second, and you can see the time frames over here as well too. And then it goes back to a neutral position. If you're trying to wow your customer, have it do a loop, and then it would continue to do this. If you wanna go ahead and just rest your head on your elbow and sleep, and you can just have this moving in the background, we're good too, so. Yeah, you could do it as a, yeah, and what it is, yep. And down here, what you can do is you can click a button and it'll spit it out to the actual motion study at that point. So, and it'll put in the time frames and you can do whatever you need at that point. It has the make controller. It doesn't have the ability to save those out as configurations for the positions. Yes. Yep. Sure, yeah, yeah. There's always way outside the program you could do it. And it animates, well, and everybody has access to the animation portion of it. So that's, I mean, that's something that comes in standard all the way through. The key benefits of this, as far as making animations, would be, the visualization package in 2017 can actually pull those animations in. So you can get high-end rendering plus the ease, and I say ease of animations in SolidWorks, but it does have some bonuses to it, so. Oh, that's right. eDrawings can support in 2017. I forgot about that. Yeah. So you can animate that, save it as configurations, and send it to your customer, and then they can watch the animations through eDrawings. So, that's a good one. Thanks, man. Think about that. Thank you. Appreciate it, guys. Thank you very much.